Imagine the sound, a low planetary rumble that grows into a deafening hiss. This is the sound of the world's oceans reaching a boil. For this to happen, sea surface temperatures would have to hit about 101 degrees Celsius, just a bit higher than freshwater because of the salt. The cause? A runaway greenhouse effect. A vicious cycle where heat creates more water vapor, a potent greenhouse gas, which in turn traps even more heat, causing more evaporation. The atmosphere becomes a thick, suffocating blanket of steam. Global temperatures soar. The planet's hydrological cycle, the engine of our weather, collapses. The very concept of rain becomes a distant memory. All the water is now in the air, trapping heat, and the world begins to bake. First, all marine life is gone. A silent, sterile extinction event in a vast, empty basin crusted with salt. On land, the planet's great thermal buffer is gone. Without oceans to absorb and distribute heat, temperatures swing to unimaginable extremes.
Scorching days that can melt lead give way to nights that freeze solid. The Amazon, the Congo, these great rainforests, which rely on oceanic evaporation for their lifeblood, wither and burn. Fertile plains turn to cracked desert. The world's food chain is severed at its base. With no phytoplankton, the foundation of marine life, the entire web collapses. Humanity's food supply vanishes. Coastal cities, home to billions, become meaningless markers on the edge of a great abyss. The global economy, so dependent on shipping, fishing, and tourism, simply ceases to exist. We become a species of scavengers on a ghost planet. So, is this a glimpse of our future? The short answer is no. Scientists are clear. A true runaway greenhouse effect, driven by the sun's slow, inevitable brightening, is at least 1 billion years away. Our current actions, however, damaging, aren't projected to push us over that specific cliff. But the thought experiment reveals the fragility of systems we take for granted. Take the Atlantic Meridional Overturning Circulation, or AMOC. It's a massive ocean current, a conveyor belt moving heat around the globe, regulating our climate, and it's weakening. Some studies suggest a collapse could begin as early as 2055. This wouldn't boil the oceans, but it would trigger its own chaos, plunging Europe into colder winters and altering rainfall worldwide. It's a stark reminder that our planet's stability rests on these moving parts. In a twist, scientists have also recently observed an unexpected decline in global ocean evaporation, not because it's cooler, but because of a phenomenon called wind stilling. The winds are slowing down. This complicates our climate models and proves just how much we still have to learn. The horror of a boiling ocean isn't in its likelihood, but in what it teaches us about the world we have now. It forces us to see the oceans not as a boundless resource, but as the central organ of a living planet. They dictate our weather, our food, and the very air we breathe. Their currents are the circulatory system, their evaporation the breath. The scenario isn't a forecast, it's a mirror, reflecting the profound consequences of disrupting a system of such intricate, delicate balance. We don't need to imagine the ultimate catastrophe to recognize the warnings our planet is already sending. The real story isn't the boil, but the slow, simmering changes we can still address. Our oceans are the planet's heartbeat, and we don't need them to boil to know it's time to listen.